Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, welcome to Lesson 27, Recursive Challenge Problem, the double and add 5 game. So this is a continuation from Lesson 26, and the double and add 5 game is loosely related to the Collatz conjecture, an unsolved conjecture in mathematics named after Lothar Collatz, who first proposed the problem in 1937. He is a German mathematician who died in 1990. The conjecture includes a recurrence relation, triple, and add 1 as part of the problem statement. It is worthwhile activity for you to read about the conjecture online. So I highly recommend Googling the Collatz conjecture. It's pretty cool. Anyhow, classwork example. Recall exercise 3 from the previous lesson using a generic initial value a sub 0 and the recurrence relation a sub I plus 1 equals 2a sub I plus 5 for I greater than or equal to 0. Find the formula for a sub 1 through a sub 4 in terms of a sub 0. So we've already done this in the prior video. So if you did the video if you watched the video for lesson 26, then this is a continuation. Okay, so we want a sub 1. So I write a sub 1 equals in terms of a sub 0. So how do I get 0 here? What does I have to be? Okay, so a sub 1, I'm sorry, what we want a sub 1, we want this to be a sub 1. What does I have to be? Well, it's 0 plus 1, so I is 0 in this case. So a sub 1, which would be a sub 0 plus 1, is a sub 1 equals 2a sub I, which is 0, to a sub 0 plus 5. Okay, easy enough. And let me switch colors for a sub 2. So then a sub 2 equals, so now let me erase this 0 here. Now I want I plus 1 to equal 2. So if I plus 1 equals 2, then I equals 1. Okay, so that would be a sub 2 equals 2a sub 1 plus 5. 2a sub 1 plus 5. But we already know a sub 1 is this, so I will rewrite that as 2, and then I'm going to substitute in my a sub 1, that's a 1 there. 2a sub 1 is 2a sub 0 plus 5. And then, don't forget we have this plus 5 here. So 2a sub 1 plus 5 equals 2 times a sub 1 plus 5. Okay, so now we need to distribute. So this would be 2 times 2, but we're going to represent that as 2 squared. 2 times 2 is 2 squared. A sub 0. And then 2 times 5 is 10, plus this 5 is plus 15. So a sub 2 is 2 squared a sub 0 plus 15. Okay, now let's change colors to blue and do a sub 3. Let me erase this here. So now I want I plus 1 to equal 3. Therefore, I has to equal 2. So that's going to equal 2a sub 2 plus 5. Well, that's going to equal 2, this 2 here, and then it's going to be a sub 2, which is this, so it's going to be 2 times 2a sub 0 plus, well, that's 10 plus the 5 is 15, and then plus 5 after. And that's going to equal 2 times 2 times 2, or 2 to the third, a sub 0 plus 2 times 15 is 30 plus 5 is 35. Okay, moving along. So now I'm going to erase this. Okay, now I want a sub 4. Well, in order to get a 4 here, I plus 1 to equal 4, I has to equal 3. So I want 2a sub 3 plus 5. Well, that equals 2 times a sub 3, okay. So this is my a sub 3 right here. So it's going to be 2 times 2 cubed a sub 0 plus 35 plus 5. So when I simplify that, it's 2 times 2 cubed, which is 2 to the 4th, a sub 0 plus 2 times 35 is 70 plus 5 is 75. So there are the first 3 terms, or first 4 terms, I mean, for a sub. Okay. Okay, so this one's a little tricky. The first thing, what does a sub 2 mean? Well, that's the result from round 2. So a sub 2 is the result of round 2. A sub 4 is the result of round 4, and so on. So write what the statement, produce a result of 1,000 or greater in 2 rounds mean, or in 3 rounds. Okay, so it says, finding the small starting whole number for the double and add 5 game that produces a result of 1,000 or greater in 3 rounds or fewer. So that would mean a sub 3 has to be greater or equal to 1,000. So that'd be this one here. And let me get rid of those parentheses here. Okay. Alright, so a sub 3, or 2 cubed a sub 0 plus 35 has to be greater than or equal to 1,000. So that's what it means for a sub 3 to be greater than or equal to 1,000. So now we can replace what we found for a sub 3, which is 2 cubed a sub 0 plus 35 is greater or equal to 1,000. Okay, so now we want to solve for a sub 0 by subtracting 35 from both sides. And that's going to give us 2 cubed a sub 0 is greater or equal to 965. 2 cubed is 8, so I'm going to divide both sides by 8. So a sub 0 has to be greater or equal to, 8 goes into 9 once, the remainder of 1. 8 goes into 16 twice. 8 will not go into 5, but 8 goes into 50 6 times. 6 times 8 is 48 with a remainder of 2. 8 goes into 20 2 times with a remainder of 4, and there we go. So a sub 0 is greater or equal to 120.625. Okay. So a sub 0 would have to be greater than or equal to 120. Since we're having a decimal, it has to be greater or equal to 120.6, so the answer is a sub 0 is greater than or equal to 121. Okay, so I just took this a little further. So the first term, a sub 0, has to be greater or equal to 121. But what they were asking was in terms of if solved for a sub 0. So really all I wanted to have was 8 a sub 0 greater than or equal to 965. Or 8a sub 0 plus 35 is greater than or equal to 1000, which is right here. Alrighty, page 2 brings us to exercise 2, and it says solve the inequality derived in exercise 1. So I kind of have already, I just went a little crazy on that last one. Once I have something, I just go with it, and I kind of did that problem here. So we want to go back to this circled item here in part 2, and we want 8 a sub 0 plus 35 is greater than or equal to 1000. So 8 a sub 0 plus 35 is greater than or equal to 1000. Okay, I want to solve this by subtracting 35 from both sides, like I did in the previous page. So it's 8 a sub 0 is greater than or equal to 965, and divide both sides by 8, and that gives me a sub 0 is greater than or equal to 965 over 8. That was a decimal, so we'll just leave this as a fraction. So you should say I interpret a sub 0 to be greater than or equal to 965 over 8. Or that was 120.625 as I showed in the previous page. And I'll just show that again. So a is greater than or a sub 0 is greater than or equal to 120.625. Okay, so that is the set of all starting numbers that reaches 1000 or greater in 3 rounds or fewer. Therefore, the smallest starting whole number is 121. So that's, whoops, wrong direction, whoopsie. So that's what I had here. All right, and that would result in, if you did that, 1003 after 3 rounds, where 120 results in 995 after 3 rounds. I'm not going to show that, but you could calculate that if you wish. Okay, here's exercise 3. Let's see, I'll do this one in red. Find the smallest starting whole number for the double and add 5 game that produces a result of 1 million or greater in 4 rounds or fewer. So I want a sub 4 is greater than or equal to 1 million. Oops. Can't talk and write at the same time, I guess. 1 million. Okay, a sub 4 greater than or equal to 1 million. Well, if I go back 2 pages, a sub 4 is 2 times 2 is 4 times 2 is 8 times 2 is 16, a sub 0 plus 75. So let's just do that. So it's 16 a sub 0 plus 75 is greater than or equal to 1 million. Okay, now we're going to solve for a sub 0 by subtracting 75 from both sides. So that is going to give me 16 a sub 0 is greater than or equal to 999,925. And then I divide that by 16, divide this by 16, and I get my a sub 0 has to be greater than or equal to 99925 over 16. Or a sub 0 has to be greater than or equal to, and let's use the calculator for this, and I'm going to take 99925 divided by 16, and that will yield 62,495. 0.3125. Okay. So that is a set of all starting numbers that reaches 1 million or greater in 4 rounds or fewer. So therefore, the smallest starting whole number would be 62,496. Okay, whole number. This is a decimal. So I need a sub 0 to be greater than or equal to 62,496. To validate, check that starting with 62,496 results in 1,011,000. after 4 rounds, whereas 62,495 would result in 999,995 after 4 rounds. I'm not going to do that calculation. I'll leave that to you, but this is the answer. A sub 0 has to be greater than or equal to 62,496. Okay, page 3 brings us to the end of lesson 27. Review the lesson summary and go to your problem set.